This may be one of the most boring skills in app development. However, if you're using Firestore and you don't know how to migrate your data safely, you could run into massive issues where your current users all of a sudden have a dysfunctional app, users that are using old versions of your app all of a sudden run into a bunch of bugs. You could ruin a bunch of their data, corrupt a bunch of their data, or even introduce a bunch of bugs for the users that download the update for your app. This is also a major problem if you started your app, you released a version of your app, but you released a version of your app that wasn't prepared to have database migrations take place for future versions of your app. So your database migration strategy is something you want to get nailed down at the beginning of development before you even release your first version of your app. You can grow, adapt, and evolve it as time progresses, but this is a very important skill, so let's jump right into it. This is the Firestore migration strategy, why you need a plan before you publish your mobile app, a guide to handling schema changes in a distributed environment. So let's jump into this. So this is the nightmare scenario. You just shipped a massive update to your app and you changed a variable called full name to be a variable called first name and last name. All of a sudden you want to store somebody's name as two different variables. But the problem is 40% of your users haven't updated their app yet. They are writing old data while your new app crashes looking for the new data. Mobile apps are distributed hardware. You cannot force a sync. So this is something that's a little bit different from web applications. When you have web applications, you deploy a change and all of your users are using the most up-to-date published code. But the problem with mobile apps is that code is stored locally on their device. So when you deploy a change, that code isn't necessarily updated on their device. So their code can be expecting an old version of the database. Now, fortunately, Firestore is a NoSQL database, document database. It's flexible. You're able to essentially read and write without matching the schema perfectly, but this can still introduce some major problems. So let's look at this little illustration that's going to help us understand these problems, and we'll elaborate on this illustration as we go so we can see how we can safely migrate our data. Basic setup, as I described before, you have your mobile application and you've released version 1, and your mobile application has this property called name in your user struct, right? This would probably be a struct, and you've got some kind of Firebase service that's managing network calls between your app and your Firestore. Now, Firestore, you've got all your collections if you've ever used Firestore before, and then when you go through a collection, you have each of your documents. Let's say this is your user collection. You've got each of your documents, and then one of these documents is like this guy, and it's got this name field, which is a string, right? And so you take that and you plug it into here, and then in your actual iOS app, you would have the user's name appear in various UI elements. So that's essentially the situation we're working with. Very, very chill, regular situation. Let's ignore that slide for now. So the version gap. The version gap is you have 20% of your users using app v2. You have 50% on app v1.9, 20% on app v1, and 10% on app v1.0. Essentially, what I'm illustrating here is you have the version gap problem, which is that when you have mobile devices, as I said, some users can be using old versions of your code, other users can be using new versions of your code. So to illustrate this, let's look back at our example, the slide that I definitely didn't already show you. We still have this Firestore database. You've got all of your data in there from users that were using V1. They've been, signing up, all this bullshit. That's fucking great. But now you have released this update. And this update leads to V2, where you have your user model and you're storing first name and last name. So what could the problem be here? Well, you could quickly see that the problem that can arise is, first, you have some users that are using V1 and you have some users that are using V2. This is fine for V1 users because they're just going to go fetch their data and then they're going to get their data and they're going to be like, hey, this is great. However, V2 users, as soon as they open up their application, they're going to go fetch their data, and when they return that data, you're going to get a codable problem, right? Because all of a sudden, oh shit, like I don't have first name and I don't have last name in the user database. So you need some kind of migration system in order to make that work. And we're going to look at a couple of possibilities for that. Another situation, let's say when you release this update, you also run some kind of like Python script that automatically creates a new user document and automatically takes that name and splits it into first name and last name. Well, that's good. Now, when your V2 users, anybody who updates their app, when your V2 users go to fetch their app, they're going to say, hey, here is the data that I need. But bam, that's very good. That's very exciting. I should make all that green because it's good, but whatever. That's fine, but now you've introduced this problem. Oh shit, I just got rid of that whole thing. Well, you've just introduced this problem where when your V1 user goes to fetch that data, this no longer exists because you ran that Python script on all of your documents. So now when they go to fetch their data, if they're still on the old version, they're going to have an error. Now there is a migration strategy that you could use here, which is if it pulls in that data, show an alert to the user that says, hey, you need to update the app. That's a very easy strategy. But in order to use that strategy, you have to have coded that into V1. You can't be releasing that code over here to tell the app to display this error if the data is outdated. So let's go ahead and jump forward and see what a couple of these tactics are. So migration strategies. Ignore that one. That didn't exist. Man, I really need to proofread these slides a little bit more. All right, so here are 3 migration strategies that we can use. You have client-side migrations, in-place migrations, and duplication migrations. There's also this alert idea that I honestly just came up with during the last slide. Maybe I'll do another video about that. There are arguably infinite migration strategies that you could use, but these are 3 pretty solid categories that you can kind of fall into and then have some what's the word I'm looking for? Just some flexibility around, some options within. All right, so today we're going to look at client-side migrations, and I could do another video about in-place and another video about duplication. Could also do another video about alert-based. So client-side migrations, you're essentially migrating data only when it is read by the client. In-place migrations is you're essentially stacking all of your data in the same collection and in the same document. So each document is capable of serving every possible version of the app. And then in your duplication strategy, essentially what you're going to be doing is each app version has a dedicated collection version. So what this looks like is you have different collections. You have users underscore V1, users underscore V2. Now each of these strategies have advantages and disadvantages. They each have different options and how you actually implement them in order to handle different circumstances, and they're both each going to be optimal for different circumstances. But again, today we're just looking at client-side migrations. But as you can see, this can grow in complexity. Client-side, also known as lazy migrations, essentially involve this system. This is a pretty common system to use as well. Essentially, your client app is going to read the data from the database, and the client is going to request documents, and the app is going to essentially check for the existence of old fields or check for the existence of new fields. Then you're going to transform that data. So if old data is found or new data is not found, the app is going to locally parse that data into the new format. It's basically going to perform some migration, and then it's going to write that data back to your database. The app silently updates the record in the background so that the next fetch is clean. Basically, that data is updated. You also have two options here. You can either overwrite or you can stack, and we'll look at what that means. With some visuals. I do love my visuals. So I'm going to use green now, or maybe orange, seems nice. So it's essentially what this looks like is you have your Firestore collection. This is really a document. You're going to read that document into your app, and then when you read that, you have this if condition. That if condition is basically taking some condition. You're going to define what that condition is. It needs to be some defining quality of your migration, and that could be, in this example, we could say, hey, does the document still have a name field? Or we could say, hey, does the document have a first name and a last name? If not, then we're going to execute some migration, right? That might be code that takes, name, and then says like, okay, you have some words, and then you have a space, and then you have some words, or some letters, and then space, some letters. Let's, put this into first, and let's put this into last, and then let's write that back to that document in Firestore. Very good. That's great. That is a client-side migration. One option that we have, this is very useful for shared data. And what I mean by shared data, let's look over here first, not over there, is let's say you have a collection with documents that multiple users could have access to. If multiple users have access to the same documents in Firestore, you got your collections, and then, this is your users collection. You have your different documents, and then, each document has their different fields, such as name. And then these are your clients, right? This is your version 1, this is your version 2. You have some users still on version 1. You still have some users on version 2. If this is a social networking app where I may be friends with, user 2, user 1 could be friends with user 2, and user 2 is now on V2, and user 2 migrates V2 or migrates their document. Well, now when user 1 goes to fetch user 2 to look at their friends list, you're going to have this is bad, so we're gonna use red. You're not going to be able to fetch that data. You're going to have a bug, right? So when you have a situation like this where you have shared data between multiple users for some collection or for some set of documents, then you're going to, in the case of client-side migrations, you might want to perform, how do I move this thing? Here we go. You might want to use a stacked migration. So this is essentially what we did before, but instead of our migrate getting rid of that name field and just leaving these two, you could just leave that name field and then have your fetch parsing or your codable parsing essentially use optional fields and find that name if it still exists. Or in the case of V1, it's going to go in and it's going to find that name property and it's going to decode it, and V1 is still going to function. In the case of V2, it's going to go in and it's going to find first name and it's going to find last name, and that's going to work as well. So that's essentially what we want. That's very useful. This is essentially stacked client-side migrations. The next option that we might have is explicit versioning. So instead of having our condition be based on some abstract, does the user field have, or does the user document have a first name field and a last name field? That's kind of a bitch to implement. Instead, you might just use a version tracker. So you'd say like, okay, in this case, this is version 1.0, and then when it comes down here, we'll say, okay, this is the updated version of our app. So it's going to say, hey, is the version still 1.0? If it is, then let's migrate. and let's throw that new data up here. And again, you could still be using, if this is shared data, you can still be storing name in there. You don't necessarily have to override it. You could stack that data. And then now you're going to say, okay, well, now version is equal to 2.0, right? That's essentially explicit versioning. You've got to, plan ahead if you want to use this, but that is an option available to you. Now, we can talk about more things next time. If you guys enjoyed the format of this, if you guys enjoyed this video, please like, please subscribe, and we can go over things like duplication strategy. We can go over things like more options that you might have. We can go over whatever those other strategies were. Honestly, I'm forgetting them all. But that is it for today, folks. Like, subscribe, and comment if you have any thoughts or concerns. Thank you.